Hello everyone, today I am going to show you about this structure called tensegrity structure or tensegrity table. Well, the word tensegrity comes from the combination of words tensional and integrity because this structure depends on the integration of tensional forces in it. So as you can see, this structure looks pretty gravity defying and floating, but that is not the truth, and the truth is hidden in the structure itself. So without any delay, let's uncover the science behind it. Criteria for a tensegrity structure. It needs to have components, and those components that are in compression and in tension. And in this structure, the strings, all these three strings are in tension, and these beams, they are in compression. And the other criteria is that it needs to have at least two separate parts that are only joined by parts in tension, usually strings, and are entirely separated from each other. So these two parts are separated from each other and joined only by parts that are in tension, these strings. Components of tensegrity structure. There are two identical structures, as we know, and these two identical structures are joined by these three strings that are in tension, and these beams are in compression. And this is the middle string. These two are the side string. So that was the. How is this structure stable? This structure is stable as any way you try to collapse the structure, there ends up at least one thread being stretched or in tension. And as we know, when a string is stretched, it holds a pulling force. So as you can see, now I have got a rubber here, and when I pull this rubber by its both ends with my hands, then we can say that this rubber is in tension or it is being stretched, and it is hence holding a pulling force. So this rubber and the strings of this structure both act pretty similarly. They both have a great tensile force. That means they can handle the tension pretty well. But the compressive force that they can take is zero. But in this structure, compressive force is put on the thread, but the structure is still stable due to the right integration of the tensile and compressive forces. So if we put pressure above this string, then this string will get in more tension and this string will get in compression. So as we put pressure above this string, then the structure tends to fall this way, but this string will get in more tension and this string will hold the structure from falling this way. So the similar way happens when pressure is put over this string. Now the middle string is in tension as it is being pulled in its both sides by these beams, and this string is also very important as this string plays a very important role to keep this structure intact. So the center of mass of this upper structure is here, and hence the upper structure tries to go this way, but these three strings, they are in tension and hence are holding a pulling force towards this direction. So the force towards that direction and the force towards this direction, they cancel out and the structure ends up maintaining its equilibrium. So what might happen if this structure is pushed in that direction? Let's try it out. As you can see, this structure just got distorted, and that is because when it is in this form, there are no strings to support the structure when it tends to fall this way. So in this way, no matter how you try to distort the equilibrium of this structure, unless you try to push it in that direction, this structure is stable and it maintains its equilibrium. So let's look at the applications and uses of tensegrity structure. An example of tensegrity structure in nature is the human body itself. In our body, the bones are in compression and the tendons, muscles, and ligaments are in tension, and we occasionally find them in tensegrity-like arrangements. Another great example of tensegrity in nature is a spider silk. There is the application of tensegrity in the spider silk too. Similarly, constructors have created a bridge using tensegrity structure and its principle located in Brisbane, Australia. And just for general knowledge, this is not the only form of tensegrity structure. There are also other forms. Tensegrity structure is also widely used in long span structures in civil engineering. This is due to its super lightweight features, making a clear span of more than 200 meters easily achievable, which can outperform other long span structures such as double layer grid and single layer lattice domes.